Hello there, Algebra. This is Mr. Zabo. I'm back to start talking about adding and subtracting square roots. Just like before when we were adding and subtracting like terms, we were combining like terms, stuff like 2x plus 5x would give us 7x. We're doing the same thing. When we're talking about adding and subtracting like terms, the only way we can combine like terms, or adding and subtracting radicals or square roots, the only way we can combine them is if they are like radicals. That means the coefficients can be different, that's fine, but the radicand, the items that are inside the square root, they have to be exactly the same. That's the only way we can combine these, and we would combine them in the same fashion. So 2 square root 3 plus 5 square root 3. They're both square root 3. The 3 inside is identical. I can combine my coefficients. It's an addition problem. I'll take the 2 plus the 5 to give me my 7, but just like I didn't make this x squared or 2x, I didn't do anything with the like terms of x, I don't do anything with the like terms of square root 3. We treat that like a variable, and it's just 7 square root 3. Similarly, we can't add 2 square root 7 plus 5 square root 3, just like we can't add 2x plus 5y. Those are different variables, those are different radicals, different square roots, the numbers inside the radical are different. I can't combine them. And you can see that if I take the square root of 7, I get a much different decimal than when I get the square root of 3. They're different, I can't combine them. Okay. So, with that said, we've got a handful of example problems that we can look at together here. Like radicals, like radicals, like radicals, but one of them's not. So that's treated a little bit different. So go ahead and pause, see what you can come up with examples 1 and 2, and then we'll talk about number 3 together. For numbers 1 and 2, they are like radicals. We have the square root of 6 in the first one. We have square root of 7 in the second one. So we can add the coefficients, the 3 plus 5. I get my 8 square root 6. And then 4 minus 1. So remember that square root of 7 does have a coefficient of 1. So it becomes 4 minus 1, or 3 square root 7. What you have to be careful of in number 3 is the fact that you have 2 terms in here that are like radicals and one that is not. You can combine the 2 that are like radicals and not the one that is not a like radical. Okay, so we treat this that we would treat negative 2x plus 5y minus 3x. Negative 2x and minus 3x can be combined. They both have a x as your variable. Plus 5y would just be not combined. It would stay in there. Okay? This is done the same way. So we have, get my highlighter out, a negative 2 square root 10 and a minus 3 square root 10. Those are considered like terms, like radicals. We can combine our negative 2 and our negative 3. Negative 2 minus 3 is going to get me negative 5. That's how many square roots of 10 we have. And make that a little bit of cleaner 0. Okay. But this I don't get rid of. I have to keep it in the problem. It stays as plus 5 square root 5. And now I'm done. I don't have any more terms that I can combine in this case. That is as simplified as I get. There's no decimals. There's nothing that can be simplified inside the radicals. Now, what about problems like this? We can look at it and at first glance we say, well, we're done. There's no like radicals, no like terms, we can't combine it. But there's a difference. Do you see it? Hopefully you do, and if not, I'm about to point it out to you, so you will. This is great. 8 root 5, nothing that can be done here. But the square root of 125 can still be simplified, and we have to simplify it to know if we have like radicals. So I'll write that down here. We need to simplify this first. When we do that, we get 8 square root 5 minus 5 square root 5. Because the square root of 125 is the square root of 25 times 5, or 5 square root 5. Now they are like radicals, and now we would have to combine them. 3 square root 5. So when we start with 8 square root 5 minus the square root of 125, we don't see it immediately until we simplify our square root. That simplifies to 3 square root 5. So make sure you always look to simplify your square roots before you start combining. That's going to be the key to the more challenging parts of adding and subtracting radicals. Take a minute and try the next two real quick. See what you can come up with. For number 4, the 4 square root 3 is already simplified, but 2 square root 27 is not. The 2 comes down, 27 is the same as 9 times 3, 9 is a perfect square. Square root of 9 is 3. We can multiply our new coefficients together. We get 6 square root 3. Now we do have like radicals. Now we can combine them to get 10 square root 3. For number 5, we should get 2 minus 3 square root 2. Again, the 2 isn't even a radical. We can't simplify it. Square root of 18 simplifies to 3 square root 2. And it's a positive because it was plus. Minus 6 square root 2. That can't be simplified, so we keep bringing it down. The coefficients for our like terms are a plus 3 square root 2 and a minus 6 square root 2. Positive 3 minus 6 is negative 3, becomes a minus 3 square root 2 as my new coefficient. All right, next two are multiple choice. This is kind of a way to check your understanding right now. What I'd like you guys to do is try these two problems, see if you get them right, and then once you check your answers here, be honest with yourself. Do you totally get this? Are you kind of getting it? Or do you need help? Okay. Go ahead and do these two problems, please. From here, without correcting this mistake, you guys would have all been circling down here. Maybe I kind of get it or I need help. There are a couple of typos here. I apologize. That's my fault. Part A should be 6 square root 3 and part B should be 4 square root 3. So those are your multiple choice options. Hopefully that helps clarify. If you haven't finished these, try them again. So these answers should be B. I've included a little bit of work in there to help you out. I'd like you to take this moment to circle something at the bottom. If you're circling, I totally get it. Awesome, you guys are in really good shape. Go on to the next page where there's a couple of practice problems where we will post answers. If you're circling, I kinda get it, maybe shoot us an email. Let us know that you have questions, that you're struggling on a certain aspect of something. If you circle, I need help, and that's what you're being honest with, that's when you know you need to reach out to us specifically. It might be we can give you more resources. It might be a Google Meet session where we can kind of work with you one-on-one. But if you're circling, I totally need help, or I need help, I don't get this, please know that that's your opportunity or that's your indication that you need to reach out to us. Okay? If you're in the totally get it or I kind of get it, even if you're in the need help, it wouldn't hurt now to switch to that next page. And there's a couple of tough ones on there. Give them a try. See what you can really do with those tough problems. I'll be posting an answer in this video in about 10 or 15 seconds, and then the answer key will also be posted for you. We go with number 6. Go ahead and follow through on the work, and if you have questions, please don't hesitate to let us know. And for number 7, there's our answer. Good luck with everything. If you have questions, again, don't hesitate to let us know. We're going to do a little bit of division tomorrow, and then follow up with some more practice and a mini quiz at the end of the week. Good luck with everything. Hope everybody's doing well, staying healthy. Take care.